Hello, my name is Sarah Mulholland, and this is my video response to Unit 4. I will try and speak to the camera as much as possible, but I have made myself some notes on my computer, along with copying down the questions in an effort to answer the questions as effectively as I am able. So please forgive my glances down at the screen. Question number 1 asks, explain the theoretical implications of Piaget's stage theory. It then further states that the implication referred to the big theoretical picture of Piaget's thesis and not necessarily a description of each stage. To me, the obvious implication here is that there is an assumption that the teacher will be in a higher stage of cognitive development than the student, at least for any information they would be teaching that particular student. Piaget's theory essentially lays out the idea that there are multiple stages of cognitive development for an individual and that an individual's stage of cognitive development will directly impact how they are able to learn, comprehend, and engage with new information. This immediately creates a cognitive gap between the teacher and student in terms of how they would address the topic, so that then if it's left unrecognized by the teacher, it mitigates their ability to teach that student effectively. My understanding of Piaget's theory leads me to the understanding that the knowledge of a topic does not necessarily qualify someone to teach that particular topic, unless they can do so in a way that accounts for the student's stage of cognitive development and allows them to learn in a way that they can construct the knowledge for themselves with helpful prompts from the teacher rather than just being told how to do it or left to fend for themselves. I believe that this leads fairly well into question 2, which says that the lecture states that a lot of teaching turns ineffective because many teachers do not realize the issues of CI existing between learners and teachers. Then I would need to define cognitive incommensurability, including an example of a teacher's instruction that disregards CI between the teacher and the student or students. So, cognitive incommensurability, which I am going to refer to as CI from now on for the sake and ease of pronunciation, is a difference or gap between two people's understanding of a topic. I believe it states in the lecture that the gap between the two is so wide that the two parties are qualitatively unable to comprehend or understand each other, at least not fully. I know it was stated in my response to the implications of Piaget's theory in question 1, but one of the main reasons this can lead to ineffective teaching is failure to recognize that CI is present. The lecture stressed the importance of the fact that simply telling a student something over and over doesn't necessarily mean that they agree with you, and it also doesn't necessarily mean that they are comprehending what you are saying. This was illustrated by the cockroach in the orange juice example. There was some orange juice in the example where the teacher had completely disregarded CI, and then the teacher attempted to teach their student in a way that was beyond their comprehension. So just because the teacher had insisted that the orange juice that had the cockroach inside of it was still okay to drink, it does not mean that a student would willfully, without question, drink the orange juice, because the student has not had a chance to analyze the situation and also construct their own reasoning behind the orange juice being safe to drink if it is. A good example of a teacher disregarding CI between themselves and students would be the Joe's boat problem mentioned in the lectures. Students do not inherently know how the flow of a current, one way or the other, will affect the boat as it crosses the stream, and often, rather than being allowed to construct the knowledge for themselves by being able to be given the chance to interact with a similar situation in real life, such as trying to walk different directions on moving walkways at an airport, like the lecture later suggested. Students are just then handed the formula for solutions. While the formula could technically get them to an answer, it does ignore the fact that while the teacher may comprehend how the current will affect the boat, the students do not. And then they are forced to rely on the teacher's provided formula just to make do. Let me go ahead and move on to prompt number 3, which states, explain dual epistemology. So, fundamental to dual epistemology is the idea that knowledge is not one thing, but rather that it falls into two categories of concrete knowledge and abstract knowledge. Hence the name dual epistemology, because we have to approach each of these separately. In order to be more effective teachers, and for that matter, better learners, it is helpful to know how we divide knowledge into these two categories and how each type of knowledge is obtained. So, let's start with concrete knowledge, because at least in my mind, it is the simpler of the two. That is because things fall into this category if they are directly passed from one person to another without a need for empirical observation or comprehension of prior knowledge. The lecture uses the example of names. We are simply told that a country is called Germany and where it is on a map. There isn't really anything that we need to deduce about it, but rather it is a social agreement to call that place Germany. Same thing for people's names. My name is Sarah. It is a social agreement to call me Sarah. Or when I am learning my students' names, we are socially agreeing to call them by their name. Abstract knowledge, on the other hand, is gained through empirical observation. This knowledge is tied to the physical world and our empirical observations of it. The lecture used the example of asking what color a pencil is. In order to determine this, the pencil must be seen, analyzed, and comprehended before an answer is given. While concrete knowledge may say, this is Germany, it would be much more abstract to determine something like, is Germany a large country? Or is it mountainous? These questions require empirical observation, and while we could parrot someone else's response to these questions, there is no social agreement to the answers. In order to actually comprehend an answer, some empirical analysis must be done. I feel as though this leads well into prompt number 4, which asks me to explain the cognitive process of a person's conceptual learning and asks that I use the terms disequilibrium and equilibrium. In order to acquire knowledge, it is necessary for us to create a state of cognitive disequilibrium. The lecture refers to this as a kind of mental pain or discomfort. Our brains seek a state of equilibrium, or in other words, a place where all of our knowledge fits as we feel as though we have an understanding of things. In order to learn, we must upset this equilibrium and throw things into a state of disequilibrium. This would be a state where, as we gain new knowledge, our brain must struggle to fit in with this existing knowledge, often pushing us or making us feel mentally off balance. With gaps in our information, or possibly information that seems conflicting or incomplete with our current knowledge, we are forced to make sense of this new information. This may require mental effort in seeking out more information on a topic and may not be instantly remedied. The lecture states that in order to shift our views fully on a topic, it could take up to 5 years. Even so, without allowing for disequilibrium, it is difficult to learn. Now I'm going to transition to question 5, which asks me to explain how the way the mastermind game applies to the notion of constructivism. It also asks me to explain how it differs from direct teaching and the nativistic teaching method of let the child figure it out. I would like to start with the second part of the question. This is not direct teaching in the fact that no strategy or direct solution is given. I don't say to the participant, this right here is the absolute best way that you can win. I also don't just say, here are the rules and you just figure it out. I don't expect them to just figure it out and just looking at the rules that way. Which would, in this way, would be similar to, or would be the nativistic approach, which we just don't give them that. So instead, I am asking questions that force the participant to analyze and evaluate what they know or how they should approach their next guess. As for how this game applies to the notion of constructivism, the only concrete knowledge provided to them is the rules of the game. But the solution to the code requires some abstract knowledge. I played this game with my husband, and it was fun to watch him quite literally try and mentally construct a strategy to figure out the correct answer. Several times when I asked, "What do you know now?" he would tell me only to then have to reevaluate after his next guess because he didn't actually know what he thought that he knew. The beauty of this is you could watch him experience disequilibrium and then have to fill in the gap. Why didn't this line up with his previous thought of what he knew? He would reevaluate and find out, this is why. You could see him get better and better in real time as he constructed a strategy and then eventually not only broke the code, but he also became more efficient at breaking the code in subsequent games with new codes. I'm going to move on to questions B, which asks me to describe 2 teaching methods in a subject or topic of my choice that serves to qualitatively enrich the learner's cognition. It also says to keep in mind my teaching method and that it must provide cognitive disequilibrium to the learners. In my answer, include a theoretical justification for the teaching method. It then further asks that each teaching method target a different student. So, for part A, I will be listing a teaching method for a child in the pre-operational stage. So, for the child in the pre-operational stage, the teaching method I chose was addressing fractions using math manipulatives. So rather than giving my students a lengthy lecture on fractions or parts of a whole, I would give the children concrete materials like the manipulatives I have here. So their manipulatives would not be glued to this piece of paper. They would be able to move them around. So they would have a square. Then I would provide each student with a set of manipulatives and then ask them questions that would require them to formulate a response. So perhaps I would start with asking students to fill in this square. And they could approach filling in this square in a variety of ways. I might then ask them if there is any other set of pieces that could be used to fill in a square. So for the square problem, I would give them different manipulatives, again, not glued to this paper, but they would be able to move them around. Maybe they're gonna have all these pieces and not in an organized way necessarily, just, each set for each student. And then maybe they choose to create the square using half of this one and half of this one. So they might use 3 different pieces, or maybe they see all 4 and put the square together, or they do it this way, or come up with this on top. Maybe there's many different ways that they could use these pieces to create this square. So then we might move to filling a more complex shape, like a rectangle. This would be all the while students would be asking what pieces accomplish the task. Are there other combinations that work? And are there any pieces or combinations of pieces equal to each other? So now that we have a rectangle, we take this square. I'm going to give them another square, okay? So now they have 2 squares or a rectangle. They now need to take this rectangle and use their manipulatives to fill in the rectangle. They have more choices now too. So they have several strips that equal a square. They've got the 3 pieces that equal a square, but they also have these other pieces here to equal squares. And so what are they going to choose to create their rectangle, which is 2 squares combined? So unlike direct teaching, this allows the students to experience disequilibrium and construct the knowledge of how to fill the shape, which may not always be doable with one type of piece. For the second teaching method, I am asked to target a student on the verge of concrete or formal operation. I would give the student the assignment of a debate, okay? The student would be given a prompt on a previously discussed topic that they have a concrete operational knowledge of, but they lack formal operational knowledge of such as the prompt, say, is climate change an issue in modern society? The student would then be given a task of preparing for both sides of the debate, the opposition and the affirmative. The student will be given time to prepare both, but they will not know which side that they will be debating on until the day of the debate arrives. Then at that point, they will be assigned a position and asked to debate from that position. This not only causes the student to fill what remaining gaps they have in the knowledge about the topic, but it can also cause an extreme amount of disequilibrium, as the student will have to both research and defend both the position that they likely agree with and the one they don't, and come up with valid arguments that support that viewpoint. This should allow a student who is already in the concrete stage for this topic to help make the jump to formal operation. I hope you enjoyed my answer to Unit 4. Thank you.